I am Professor Shivkumar Balagaon, Assistant Professor, Department of Humanities and Sciences, Walchand Institute of Technology, Solapur. In this video lecture, we are going to study and understand the Hungarian method to solve a given assignment problem. In the beginning, we will see the learning outcome of this particular content. At the end of this session, students will be able to understand the significance of assignment problems in real life applications, and they will be able to apply the Hungarian method to obtain an optimal assignment. Now let us discuss Hungarian method with the help of one example. The example is find the optimal solution to the assignment problem with the following cost matrix. This matrix is given. Friends, see why this matrix is called as cost matrix. Because in this matrix you can see there are 4 works to be performed by 4 men. So basically this is 4 by 4 cost matrix. As the number of rows and columns of this matrix are equal, this particular assignment problem is called as balanced assignment problem. In this matrix, the cost of performing all the 4 jobs or works by 4 men are given. For example, the cost required to perform first job by the first man is 12. Okay, like this all other costs are given. Now let us see the solution. As we said, the given assignment problem is balanced assignment problem because the number of rows and columns in that matrix are equal. Now we use Hungarian assignment method to find the optimal solution. As we all know that step number 1 is subtracting the smallest element of each row of the cost matrix from all the elements of respective rows. So the given cost matrix is taken here for our reference. We will have to apply step number 1 to this matrix now. If you look at first row, the smallest element of the first row, if you see it is 12. So according to step number 1, we will have to subtract all the elements of the first row from 12. Okay, and similarly, the same thing is to be done in all other rows as well. You can take a moment, and do the calculations. If you do all the calculations, you will get this resulting matrix. You can see 12 is subtracted from all the elements of the first row, that is 12 minus 12 is 0, 30 minus 12 is 18, 21 minus 12 is 9, 15 minus 12 is 3. Like this, the same thing is applied to all the particular rows, and then we got this particular matrix. You can do the calculations by your own as well, because all these calculations are very simple to deal with. Now we need to work on this particular resulting matrix in step number 2. Now step number 2 is we need to modify the resulting matrix obtained in the first step by subtracting the smallest element of each column from all the elements of the respective columns. Say the previous matrix is taken here for our reference. Now if we apply step number 2 this particular matrix, we get the next updated matrix, that is this. Here you can see now column wise we need to apply step number 2. In the first column you can see the smallest element is 0. Hence if you subtract all the elements of first column by the smallest element 0, there will be no difference. Therefore we got the first column as it is. And after that you can see column number 2, the smallest element is 4. So subtracting all the elements of second column by 4, we get 18 minus 4, 14, 24 minus 4, 20, 4 minus 4, 0, 16 minus 4, 12. Like this, other 2 columns are obtained. Now moving on to step number 3. Step number 3 is very important, friends. Here we need to draw a minimum number of horizontal and vertical lines to cover all the zeros. Friends, here there is no criteria as such to draw the minimum number of lines to cover all the zeros. what I can tell you is that you try to cover maximum zeros of a particular row or column. In this way, if you try and draw the minimum number of lines, it will definitely help you. So here in this particular matrix, how to draw the minimum number of lines so as to cover all the zeros, that is the question. So let's do it. If you observe, in the fourth column there are 2 zeros, you can see here, and similarly in the third row there are 2 zeros. So maximum zeros are present in third row or fourth column, and other than that, if you see, there is 1 0 in first row, 1 0 in second row, and 1 0 in fourth row. So first of all, what we will do is we will draw the line on the fourth column to cover 2 zeros, and then we draw the line along the third row to cover 1 more 0, and now we are left with 2 more rows or 2 columns. So again 2 lines are required to cover the remaining 2 zeros. So the third line is drawn to cover the 0 in the first row, and the last line, that is line along the third column, is drawn to cover the last 0. In this way, lines are drawn to cover all the zeros. So minimum number of lines required to cover all the zeros is equal to 4, which is exactly equal to number of rows or columns in a cost matrix. Therefore, we get the optimal solution, because see, number of lines, minimum number of lines drawn, if it is equal to number of rows or columns of a cost matrix, that will ensure the existence of optimal solution. Now to obtain the required solution, we need to proceed to zero assignment. Now in this particular step, we will see how to make zero assignment. For that purpose, we need to examine all the rows successively till a single 0 is found, and that particular row will be used for making zero assignment. If you see in the first row, there is only 1 0, so that 0 will be assigned. Moving to the second row, you can see there is only 1 0 again in the second row, so that 0 is also assigned. And in third row, you can see there are 2 zeros, so 0 assignment cannot be done. So we will go to the next row, that is the fourth row. And in the fourth row, you can see there is only 1 0, so that 0 will also be assigned. Now the same thing will be done column wise. We will observe the columns successively till we get a single 0. If you look at the first column, already 0 assignment is done, so we go to the second column in which there is only 1 0, so that 0 has been assigned. The 0 assignment in third column is already done, and the 0 assignment in fourth column is also done, so still there is 1 0 is remaining, so that 0 is not used for assignment, so it will be ignored. So this is how zero assignment can be made. Now with the help of this particular assignment, we can easily obtain the optimal solution. Hence the optimal assignment will be as shown below. The first work will be assigned to first man, second work will be assigned to third man, third work will be assigned to second man, and the last work will be assigned to the fourth man, so as to get the minimum possible cost. Therefore, the total minimum cost is equal to 12 plus 9 plus 25 plus 14, the sum comes out to be 60. Now you might be thinking that from where we have taken these particular costs. These particular costs are taken from the optimal assignment just now we have made. So to explain the total minimum cost, we have this particular matrix. You can see in this matrix, as per the zero assignment, the costs are considered. As the first work is assigned to first man and the corresponding cost is 12, so 12 is taken here. Second work is assigned to third man and the cost of second work performed by third man is 9, so that's why 9 is taken here. And then third work is assigned to second man and corresponding cost is 25, that's why we have taken 25 here. Lastly, the fourth work is assigned to the fourth man and the corresponding cost is 14, therefore 14 is taken here. So the sum of 12, 9, 25 and 14 is coming out to be 60. Therefore, the total minimum cost of this particular assignment problem is equal to 60. This is all about one simple and significant example on Hungarian method. Dear friends, to make this video content, I have referred to two textbooks. One is Higher Engineering Mathematics by B.S. Grewal and the other is Operation Research by S.D. Sharma. Thank you.